Right, now we've done some reactions with aldehydes and ketones, but what about some of these carboxylic acid derivatives if we wanted to do some of this aldol type reactions? How would that work? So now we have two esters, similar, the exact same esters. Similar as before, we're going to number these 1, 2, 3, 4. We're going to have carbon 2 be the nucleophile. We're going to deprotonate that, and it's going to react with the electrophile carbon 3. Notice there should be some careful selection of the type of base used. This should be CH2, CH3. The reason why that matters is because this is still prone to adding in and doing a addition elimination, but if this base you choose matches the ester, it would get the same thing back. So eventually sometimes it's going to deprotonate at carbon 2. So let's do that first. Let's do that deprotonation. So that careful selection of base really matters. So deprotonation. So what are we going to get down here? So deprot. What do we end up with? We end up with a enolate. No, negative charged carbon, carbon 2. That's our nucleophile. We're going to do that addition, just like we've done before. So that addition step, form a tetrahedral intermediate. Number my carbons, 1, 2. Form bond between 2 and 3, 3, 4. All right, 2 is my nucleophile, 3 is my electrophile. Have a tetrahedral intermediate, and now this is a little different than we've done before, because at this point, this tetrahedral intermediate actually has a good leaving group. It has a good leaving group. So what's that mean? It means we're going to do the elimination. All right, so we're just going to do that elimination. What are we going to end up with now? So carbon 3 is there. What else do we make? We actually regenerated the same base as we had before, C2, CH3. Let's do it. Make sure we number the carbons. 1, 2, 3, 4. So that bond between 2 and 3, and this elimination leads to this Claisen. It's called a Claisen condensation. It's a way, right? Net, what you did was you took two esters and ended up with an ester and a ketone. And they're in a 1-3 relationship to each other. Similar to what we've done before, but a little different because, right, since we're using esters, when we do that addition, we won't do protonation right away. We actually can do an elimination because we have a good leaving group. So a little different type mechanism, but similar, all the same. The last step calls for H+, and so all that's doing is just protonating. That second step is just asking a way to, right, when we do step there with H+, that's just a protonation step, right, to work the reaction up and stop the reaction from keeping going. You end up with that final product.